All right, so I'm barely awake right now and just decided to make a video because I thought this was cool and I want to share. Um, so armature systems are something very common in animation. It's a way to move larger bodies around without having to move each individual vertex. And you can do this in animation, 2D animation as well. Things like spine are meant for this. And so I think about these things every once in a while, and I decided I wanted to give it a shot. I really wanted to try and see if I could make a very simple armature system. And after thinking about it a while, I thought it can't be that hard. Like, you could actually probably do this very simply. And I wasn't wrong. For once, I'm not entirely wrong. So I got this really simple, like, they maintain their own angle, they move around from the bone. This square right here, that's just a body just used as a root, that all the limbs will then extend off of. It can get pretty horrifying pretty darn fast, which I think is amazing. Oh man. Yeah, and so the bones can be moved around. I can't move the body at the moment, though. Really, it shouldn't be that hard. This isn't nearly something super duper impressive, but I just wanted to share how simple it actually was. So there are two objects. In this case, we have a where is it? We have a body, which is just a step event, and we have a limb, or this would you consider this a bone, probably a linkage in the armature. And the step event is just the controls. State one. So state 0 for the basic state. Then we're just checking if we click on it, we can set it to state 1, which is actually like moving it around. And then state also, if we hold down shift and we click, it'll spawn a new bone. And then right click while holding shift will then delete a bone as well. Yeah, that's, because sometimes you just need to get rid of bones. So it's the information you actually need, though, to make the armatures and the linkages thing happen is you need a root and a node. The root is at the origin of the bone. That'll be, I just pull up the sprite here and show off. Yeah. So the blue end, that's the root, and the yellow end, that's the node. Show you again from the. Here we go. So the blue is the root, and that's where it attaches to the body or the limb behind it. And the yellow is the node. That's the thing that you can actually move around. So you establish these two things immediately, and then when the root bone is created, you set the root based on the ID of what you're setting it to. For the first bone, that'll be the ID of the body. You just set its root. For subsequent bones, it's the bone that came before it. And then the bone sets its root, is just an ID, and then sets its node based on the x plus the length through x, the sprite angle, and just the width, and then set it based on the sprite angle, the image angle, which is us rotating the bone around, so that it will always be at the end of the bone. You always have it there at the end. If the root object is the body, then we just set it to its x and y. Otherwise, we set it to the node of the bone before us. Don't worry about this. This doesn't do anything at the moment. That's pretty much it. Like, at the end of every step, every bone resets its own root, resets itself to the root, and that's basically it. It's just really, really, really simple. The other thing that we can do is actually scale the bones. So dunk, there you go. Dunk, there we go. And now if we hold control while we're clicking, I can scale the bone. And you can make the bone any length that you want. And again, it's a really simple formula for calculating the node at the end of a scaled bone. Getting the X scale. If you're holding down the mouse button, then we're changing the image angle based on the mouse's the direction from the XY coordinate of the root to the mouse. But if we're holding down Control, we're also changing the image X scale. And this is, again, really, really simple. It's the point distance of the between the origin and then the mouse divided by the base width, which we set here just to be the initial sprite width, because it always has to become 1 in the end. Let's see. Let's go back. All right. And then I was doing max here so that you can't make the bone disappear. So it just has to a base width of 0.2. You can't get lower than 0.2. And then just if the mouse button is released, we go back to state 0. And that's it. And I could simplify this further. I could take all of this out of the bone itself, put it all in like a parent object, because in the body, this is essentially the same thing. This is the same thing. It's just not checking if we're over the node because the body doesn't have a node. I probably don't even need the body at this point. I could just use bones. Yeah, that's the basics of it. And I just thought this was a super cool little thing. Feel free to pause and copy the code. It's really, really simple. The draw is just draws a circle. If the mouse is over the node, we draw a circle over the node so we can tell if the mouse is there. The step event as we've seen, and then the end step is just reset the root in case the parent bone that we're linked to has moved. And that's it. That is the entire linkage system. And just think about that. Just think about that. You have very little information is actually stored in any of these bones. They don't need to know very much. But imagine now if we, oops. Let's see. Extend this outward, extend this outward, extend this inward, and there we go. Now imagine if, like with Control S, I could save the X and Y position and everything about these bones. I could save that. And then, at a certain point, and then I could save it at this point. And, I could save it at this point. Then I could save it again at this point. And if you strung all those together, what does that kind of look like? That kind of looks like a walking animation. Think about that. Think about that. And it's so simple. Doing this, I kind of had this thought that I could do this because I wanted a system like this for doing like the spine style, like the Salt and Sanctuary style animations, because it's much easier to do like switching out armor. If you don't have to draw every animation for every armor set, instead it's all tied to a bone. It's all tied to a mesh, essentially, just like it is in 3D. I looked at Spine, and I downloaded the free trial of it, and I messed around with it a little bit. And I thought to myself, this is going to take a long time to learn. But I've had this thought since I was a little kid. It's like, what if I just made it myself? Well, the answer is, if I do make it myself, which I perfectly well could, I'm going to end up with taking the exact same amount of time it would take me to learn Spine, and I'm going to have a much worse product in the end, but it's going to be a ton of more fun. It's going to be a lot more fun to just write it myself. And, it's all in-house. I don't have to pay for a Spine license. Petty, maybe a little bit, but I don't care. It's just too much fun. So I hope you enjoyed this. I hope you learned a little something. There's not much else to it than this. I just kind of wanted to show off and just sort of celebrate how easy this was in the end, because it really was, as I thought it would be simple, and I was not wrong. Oh, that is a notable error here, is that since, let's see if I can put this back. If I wanted to spawn, it's not going to do it. If I wanted to spawn another bone right here, as you can see, it's covered up by the bone that was already there. So I can't independently select each. And like I was saying earlier, if I could pull all like the selection and everything out of the original, like out of the bones themselves, and I could move it over into a controller object, which I do have already in this project. So it's something I need to look into. But if I could go do that, then I wouldn't have to worry about I could select based on like the depth of each bone, which one, like only select the topmost bone and stuff like that. But as it stands, that's really the only real error. I could also make it so that the like child bones maintain. Let's see if I can just get to delete this. Here we go. Can well like maintain their angle not relative to themselves but relative to their parent bone. That would be more like how it really happens in applications like Blender or I believe Spine. I really didn't mess with it that much. Um, but again, this is just getting the angle difference between the parent, the parent, and then the child, and then making sure that that angle difference stays the same no matter what angle the parent is at. Oops, did it again. Meow, meow, meow. Guys, I'm so proud of myself. I just really am. So, I hope you like this. I hope you found this interesting. Feel free to pause everywhere and just screenshot the work. So you want to write this for yourself. I am zoomed way in. There is a camera. I have a special camera that's pointing at this, and so the actual limb isn't huge, but it's not small either. So have fun with this. I think this is a really fun little thing. That it was remarkably easy to do. So I mean, go ahead, dive in, see what you can do with it. And if you ever have an idea like this, just give it a shot. You know, see what you can do, and don't be afraid to set the code aside and just come back to it later. And then, bam, 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 suddenly you've got something cool that you made from all the other things you've tried. So yeah, that's it. It's Tuesday when I'm making this, so happy Tuesday to anyone. Anyway, if it happens to be your Tuesday, happy Tuesday to you. All right, have a wonderful day, everybody. See ya.